Okay, today's lesson is on fractions and decimals. Again, please make sure that you are putting your name, date, and period on each of your assignments. We are going to start with converting fractions and decimals. Values can be represented in several ways. For example, a fraction can also be represented as a decimal or vice versa. I would say probably one of the most common ones you would recognize would be the fraction 1/2, which is the same thing as 0.5. You should know that 1/2 is 0.5. They mean the same. One's a fraction and one's a decimal. To convert a fraction to a decimal, divide the numerator by the denominator. To convert a decimal to a fraction, put the decimal over 1 and multiply the numerator and denominator by 10 until there is no longer a decimal in the numerator. Then simplify your fraction. Okay, types of decimals. If a fraction converts into a decimal that eventually stops, we will call it a terminating decimal. Otherwise, if a fraction converts into a decimal with a repeating block, we'll call it a repeating decimal. All right, let's go ahead and start practicing. Practice converting the following fractions into decimals, then state what type of decimal it is. All right, so we are going to convert the fraction to a decimal, and then we are going to determine if it is a terminating decimal or a repeating decimal. So starting with the 3/8, remember the numerator is the number that goes inside, so we're going to do 3 divided by 8. Okay, now 8 cannot go into 3, so we're going to put a 0 and a decimal and then a 0. And 8 goes into 30. How many times? Think about how many times 8 can go into 30. If you said 3, you are correct. 8 times 3 would be 24. Subtract 30 minus 24, and you get 6. Now you should be doing this without a calculator. This is a no calculator assignment. Since we still have this remainder of 6, we're going to put a 0 up there again and bring it down. Decide how many 8s can go into 60. Well, I know 8 times 8 is 64, so that's a little too much. So I'm going to say 7. 8 times 7, which would be 56. Subtract. You have 4 left over, still a remainder, so keep going. We don't want to have a remainder. We're either looking to not have a remainder or start to see a repeat. We don't see a repeat. So far we've got 0.37, so nothing's repeating yet. Okay, 8 into 40. 8 times 5 actually is exactly 40. So now we have no remainder. So therefore, we can say that 3/8 in decimal form would be 0.375. And because the decimal ends, we are going to call this a terminating decimal. Remember, you have to state the decimal and say what type it is. Okay, so this is what we're doing. So let's go ahead and go over here to 1/16, and let's do the same thing. So we're going to do 1 divided by 16. Okay, can 16 go into 1? No, we know it cannot, so we add a decimal and a 0. 16 into 10. 16 cannot go into 10, so we actually have to put a 0 here and add another 0. And then figure out how many 16s can go into 100. And if you have to, you might have to just go over to the side. For example, since we can't use our calculator, if you're really not sure, if you just want to, guess 5, for example, we could come over here and do 16 times 5. 6 times 5 is 30. Carry the 3. 5 times 1 is 5, plus 3 is 8. So if we did 5 16s, that would give us 80. But it looks like we could probably fit one more in there, because if we put another 16 in there, that would give us 96, which is close to 100. So it looks like it can hold 6 of them. So 16 times 6 would be 96. Subtract, you get 4. So we still have that remainder, so we put another 0 and bring it down. Now 16 into 40, you probably could guess about how many of those would fit into there. If you say 2, I would say you're probably correct. That will give you 32. 40 minus 32 is going to leave us with 8. Still got a remainder, so we're going to bring another 0 down. Now 16 into 80, remember right here? So how many times can 16 go into 80? 5 times. So we're going to put our 5 here, and that gives us 80 exactly, doesn't it? With no remainder. All right, so we're going to say 1/16 is in a decimal form 0.0625, and because it stops, we're going to call this a terminating decimal. If you think you're getting the hang of it, feel free to pause this and try number 3 on your own, just to see how you're doing before you start back up. You should be writing all these notes down along with me on your lesson sheet. Okay, let's try this one. 5 divided by 6. Okay, 6 can't go into 5, so we do our typical little routine here. How about 6 into 50? 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 48. That's pretty close, isn't it? Otherwise, 6 times 9 would be too much. We have 2 left over, so we got to bring another 0 down. 6 can go into 20 3 times. That gives us 18 with a 2 left over. And we have to bring down another 0. Well, look, we've got 6 going into 6 going into 20 again, and we're going to have to put another 3 up here. We're going to get another 3. Oops, sorry, just a minute. We end up having another 3, and that's just going to keep happening. Watch. So we have a 2 left over. If I keep doing this, I'm going to keep getting a 3. So here's how you're going to write this. You're going to say that 5 6 is the same thing as 0.83 with a line over the 3, showing that the 3 is repeating. Okay? And so therefore, this is a repeating decimal. All right, let's look at number 4. Okay, 4 divided by 9. 9 can't go into 4. 9 into 40. 9 times what would be 40? 9 times 5 is 45. That's too big. So 9 times 4, that would be 36. What's 40 minus 36? It's 4. So we've got a remainder, which means we bring another 0 down. And now we're doing 9 into 40 again, right? So that's going to be 4 again. And it's just going to keep giving us that 4 over and over and over. So the way that we write this is we say 4/9 as a decimal is 0.4 with a line over the 4, because the 4 is repeating. And therefore this is a repeating decimal. All right, number 5. 13 divided by 4. Now remember, the top number is always the number that goes inside the division symbol there. It's not the smaller or the bigger one. It's always the numerator that goes inside. All right, so here we go. 4 can go into 13 now. It can go in 3 times. That gives us 12 with 1 left over. Now because we have a decimal, we're going to add a because we have a remainder, we're going to add a decimal and a 0. We're going to bring down the 0. 4 can go into 10 2 times. That gives us 8. 10 minus 8 is 2. So we still have a 2 left over. So we add a 0, bring it down. 4 goes into 20 5 times. 4 times 5 is 20. And now we have nothing left over. So that one came out nice. So that comes out 13 over 4 is 3.25. So we can say that that is a terminating decimal. And also, just as a little reminder here, this 13 over 4 is an improper fraction, and that's going to give us a whole number here in the front. All right, last one, number 6. We're going to do 7 divided by 9. So 9 cannot go into 7, so we do this. How about 9 into 70? 9 times 7 would be 9 times 8 is 72, right? So 9 times 7 is going to be 63. I think that's as close as we can get. What's 70 minus 63? It's 7. We add a 0 and bring it down, and look, we're going into 70 again. So we're just going to keep getting 7s, aren't we? So 7/9 is 0.7 with a line over the 7, and therefore this is a repeating decimal. Good. Very good. All right, let's go to the back. All right, now we're going to practice converting the following terminating and repeating decimals into fractions. So we're going to go the opposite way. Now, turning this into a fraction. On the other page, or on the front side, the directions say to place the decimal over 1 and then multiply by 10 until you get rid of the decimal up top. And I'm just going to show you what that means. So for example, if we multiplied by 10 up here, and of course you have to do it to the top and bottom, 0.35 times 10, it ends up moving the decimal over 1 place, so we end up getting 3.5 over, and then 1 times 10 on the bottom would be 10. And then when you times by 10 again, you end up moving the decimal over 1 more place, which gives you 35, and 10 times 10 on the bottom is 100. Well, the way I typically show you, which is fine, that's fine, and then you're still going to have to simplify the 35 over 100. But the way I typically show my kids is I tell them, take this number, okay, without the decimal, the 35, and place it over however many place values out the last number is. So this is in the tenths, and this is in the hundredths. So you're going to place the 35 over 100. It's also easy to just count how many numbers are after the decimal. 1, 2, and so you're going to put 2 zeros after the 1 there. Okay, and then you need to simplify it. So we need to think about what can go into 35 and what can go into 100. If you say 5, that's correct. So we're going to divide them both by 5. And that's going to give us 7 over 20. And there we go. 0.35 is 7/20. Okay, let's look at number 8. So again, if we just look at this, we're going to place 275 over a 1 with how many digits? 3 digits, so 3 zeros. So it's 275 over 1,000, because you're really looking at this last number and it's in the thousandths place. So 275 1,000ths. Now we do need to try to simplify it, so we've got to see what we can divide them both by. You think of something that we could divide both of these by. If you think 25, you would be correct. Now, there's other options, but 25's a pretty good one here. Think 25 would be like quarters. Think about how many 25s or quarters can fit into 75. You should get 11 over, and if you're having a hard time figuring out the bottom because we're not using a calculator, think about how many 25s make up 100. So there's 4 25s in 100. And then how many hundreds are in this 1,000? Well, there's going to be 10 100s that make up 1,000. So 4 25s in 100, and then 10 of those. So 4 times 10 would be 40. So that's as simplified as you can get it. Okay, number 9. Now, we've got a whole number here, so it's super important that you just bring the whole number down. And then this is the part that's going to be the fraction. 12 over, this is the tenths, this is the hundredths, so it's going to be 12 over 100. Now, we're still going to keep that 8, but we need to try to simplify that 12 over 100. So think about what you could divide into 12 and into 100. If you said 4, you would be correct. So 12 divided by 4 would be 3. And what's 100 divided by 4? 4 what? 4 of what would fit in 100? If you say 25, you are correct. So there you go. Okay. On to some repeating numbers here. Oops, excuse me. Let's see here. There we go. Okay, so when it has the repeating bar like this, instead of a 10 or 100 or 1,000 on the bottom, you're going to use 9s. So we've got our 888, and then there's 1, 2, 3 digits, so we're going to put 3 9s. And you do that when it's repeating. So think about what you could divide both of these by, because we need to simplify it. A lot of people kind of think 11, but because there's 3 of those numbers, we're going to divide by 111. And so that's going to give us 8 over 9. Okay, so don't let it confuse you. If it's got the repeating bar, all you're doing is putting 9s instead of 10s on the bottom. Okay, so again, we've got an 11 here, which is how many digits? 2 digits, so we're going to put 99. And then we're going to try to simplify. What can go into 11 and into 99? 11. So we get 1 over 9. Okay, and number 12. So this one, remember, we're still going to have this whole number, so we're just going to leave him here. And then we've got 0, 2 is just the number 2 over. And that's 2 digits, so it's going to be out to the hundredths place. Hold on a second, let me check something. Oh yeah, we just did one like this above here in number 9. All right, so it's 2 over 100, but so you're going to leave the 5, but you need to try to simplify the 2 and the 100. So if we divide them both by 2, 2 divided by 2 is 1, and 100 divided by 2 is 50. So there you go. Okay, we're almost done. Go down here to these word problems. Number 13 says, Amber has $5.55 in her pocket. Express this amount as a fraction in simplest form, okay? So 5.55 as a fraction. Remember, we keep the big 5, and then we write after the decimal, whatever that number is, over. There's no repeating bar. That was just part of that. So since we had 2 digits, we're going to use the 10, so we're going to have 2 zeros there, and we're going to try to simplify. So we can simplify both of those by 5. Be careful and always remember to keep the big whole number 5, okay? And then 55 divided by 5 would be 11 over, and 100 divided by 5 is going to be 20. That's not a really good 11 there, sorry. 5 and 11/20. Okay, number 14. Cody's new dog weighs 7 2/3 pounds. Express this weight as a decimal. Whoops. So 7 2/3 as a decimal. Well, that means it's going to be 7 point something. 7 2/3 is 7 point something. If you go up here, see when we had the 5.02, that means there was a whole number 5 and then a fraction. Same thing when we work backwards here. We're going to have a 7 point. So all we really have to figure out is this 2/3 as a decimal. So we're going to do 2 divided by 3. And see, 3 can't go into 2, so we put our 0 and our decimal in a 0. 3 goes into 20 6 times. That gives us 18 with 2 left over. So we go to bring down another 0, and we notice that we get another 6, don't we? So we're just going to keep having 6s, huh? All right, so if you remember right, we write that like 0.6 with a line over it. Well, let's come back over here to what we have. We have 7 point, so we don't need the 0 point because we know we've got 7 point, and it's going to be 6, 6 with a line over the 6 because it's repeating. All right, Trish entered a problem on her calculator that gave her this result on the screen. So we're on number 15, and this is the result she gets. Would this decimal be considered a repeating decimal? Why or why not? Well, let's look at the numbers that we have here, okay? We've got 0 point, and then we have 1, 8, 9, 4, 5, 2, 8. I don't see any pattern here of repeating, okay? So we're going to say, it says, would this be considered a repeating decimal? We know it's not ending because it keeps going, but it's also not a repeating. So no. No, sorry, I need to use a capital. No, this decimal does not show any pattern where digits are repeating. Now you can write something slightly different, but as long as it's similar to that. Okay, and then down here it says to summarize today's lesson, and that's something that I'm going to leave up to you, and you can write some notes down. So you need to make sure you do the homework that goes along with that. And, of course, you can always see me if you have any questions.